A very warm welcome to this video. This is Kavinmati here to present you a topic on damped harmonic motion and their types. What is a harmonic motion? Normally, every object on earth will be in an equilibrium position or in a calm state. Remember a pendulum bob. Normally, it will be in the equilibrium position or in the resting position. But when someone pushes it behind, it will move back and forth for a time and will return to its original state. The same will be happen in a spring or in a swing and lots of examples like this. So, the concept is a repetitive motion of an object back and forth when providing an external disturbances will be in an oscillatory condition, and this type of oscillatory motion is called as a harmonic motion. When plotting the motion of the oscillating object in a graph with the time in x-axis and displacement in y-axis, it will produce a graph like a sine wave. Let's get into a concept called damping. Now think like this: when an object is already in a harmonic condition, but by giving an opposite force may slow down the movement of the object and will make them attain the resting position after some time. This type of condition of an object already in an harmonic motion and reducing its speed to attain the zero position by giving an external force is called as damped harmonic motion. Let's see this example of this concept beneath. If you see, there are two springs, black and blue, initially in a harmonic motion with same displacement. Now, I am giving an external force to reduce the speed of the blue spring to reduce the harmonic motion. The left and on the right side of the image, there is given a graph which represents the displacement of both the springs. If you see, this displacement of the black spring always remains same, but for the blue spring, the displacement reduces to zero after some time. This is an example of a damped harmonic motion. Here if you notice, the harmonic motion and displacement of the black spring always be in the same state and won't attain the equilibrium state ever. This type of condition of an object not attaining the equilibrium position ever is called as the undamped motion, and this object with this kind of motion does not exist anywhere because every motion under oscillation on earth will always attain an equilibrium position after some time. Types of damping. So based on the time and oscillations made by the object during damping reaching the equilibrium position, damping is classified into critical damping, over damping and under damping. First, we will see about under damping. Imagine a pond with initial disturbances, with no initial disturbances, but when we throw a stone inside it at fraction of a moment, it produces lots and lots of ripples moving from center to outer and then disappears. This motion will disappear after some time, but it occurs gradually. So the motion which attains the equilibrium state by gradually reducing its harmonic motion from large harmonics to small harmonics and then to zero is called as under damping. The second one is over damping. Think of an example like this, a speedometer. Now we are riding a car at 100 km per second speed. If I want to stop the car, what will I do? I will apply brakes in it. Here, the speed of the car gradually reduces from 100 to 0 in a slow manner. It won't oscillate between 100 and 0, or it won't fluctuate between the speeds. It decreases slowly from 100 and then finally comes to 0 after some time. Such type of motion when subjected to damping comes to 0 or to the equilibrium position without any oscillations is called over damping. And the last concept is critical damping. The examples for this type of damping is a shock absorber. Moreover, critical damping and over damping are slightly same. But the concept of critical damping is the type of motion in which the oscillatory motion subjected to damping reaches the equilibrium positions gradually without oscillations in a short span. That of the over damping is called as critical damping. So this is the difference between the critical damping and the over damping. The graph of all the three dampings, the example for all the three dampings are given below, which explains the concept of overdamped, a critical damped and underdamped motion. So finally, I hope you all are clear with this concept, and I hope you all like this video. Thank you.